Hi friends, today we are going to discuss about top 5 commonly asking microservices scenario based interview question and answers. So please watch my channel and subscribe for more this kind of tech content, tech videos, interview based and practical scenario based interview question and answers. So my first question would be, this is a commonly asking question. Suppose your order service depends on payment service and payment API becomes slow. How will you prevent the entire application from failing? So we would, in this type of scenario, we will implement circuit breaker pattern. We would implement a circuit breaker pattern to handle these scenarios. The circuit breaker monitors the interactions between order service and the payment service. If the payment API becomes slow or starts failing repeatedly, the circuit breaker will open, preventing further calls to the payment service for a certain period. This avoids overloading the payment service and allows its time to recover. While the circuit breaker is open, we would implement a fallback mechanism in the order service. For example, we would return a default response or a queue the payment request for retry later, ensuring the user experience isn't completely disrupted. If the payment is non-critical, we might allow the order to proceed and notify the user once payment is confirmed. For monitoring and alerting, we would use distributed tracing tools like Azure Application Insights or Java to identify latency issues. We would also set up timeouts and retry policies in the HTTP client to avoid waiting independently for the payment API to respond. This approach ensures the application remains resilient and responsive even when one service is degraded. The second commonly asked question would be, order service updates successfully, but inventory service update fails. How will you maintain consistency in microservices? To maintain consistency in microservices, when the order service updates successfully but the inventory service update fails, we would implement the Saga pattern with eventual consistency using the following approaches. The first approach would be Saga orchestration or choreography. In this case, we would use choreography to let each service handle its own part of the transaction and publish events. The order service publishes an event, example order created. After successfully updating its state, the inventory service subscribes to this event, processes it, and updates its state, example reserves inventory. If it fails, a compensation event, example inventory reservation failed, is published. So second approach would be outbox pattern. To ensure atomicity between updating the database and publishing events, we will use the outbox pattern. The event is stored in the same database transaction as the order update. A background process or worker reads these events from the outbox table and publishes them to the message broker, example Azure Service Bus or Kafka. The third approach would be idempotency. All services must be idempotent to handle retries without side effects. For example, the inventory service should check if an inventory reservation request has already been processed using a unique transaction ID or correlation ID. The fourth approach would be dead letter queue. DLQ. If the inventory service repeatedly fails to process the event, the message is sent to a dead letter queue for manual intervention or further analysis. This avoids blocking the system. The fifth approach would be compensation logic. If the inventory service fails to reserve inventory, it publishes a reservation failed event. The order service listens to this event and rolls back its state by cancelling the order. This ensures that the system reaches a consistent state. The final approach would be retry mechanism. Implement a retry mechanism with exponential backup for transient failures in the inventory service. If the issue is resolved, example a temporary database outage, the system can recover without manual intervention. The next commonly asking question would be, how do you secure communication between multiple services? We secure communication between microservices using a combination of encryption, authentication, and authorization. First, we ensure all communication happens over HTTPS using TLS to encrypt the data in transit. This prevents eavesdropping, dropping or tampering. For authentication, we use OAuth 2.0 with JWT tokens. Each service validates the token's signature and clients to ensure the request is coming from an authorized source. If the system is on Kubernetes, we might also use MTLS, mutual TLS, for service-to-service authentication, where both parties verify each other's certificate. For authorization, we apply RBAC, role-based control, or PBAC, policy-based access control, depending on the granularity needed. Tools like Open Policy Agent OPA or custom middleware help ensure these policies. Finally, we limit service exposure using network segmentation and API gateways. The gateway acts as a central point for authentication, rate limiting, and request validation, ensuring only valid traffic reaches the service. The next commonly asking question would be, when will you use synchronous communication and asynchronous communication in microservices? We generally use synchronous communication when services needs an immediate response to proceed. For example, if a user facing service calls an authentication service to validate credentials, it needs the result right away to continue the workflow. We also use it for operations where the call can't move forward without the response, like fetching configuration data. So in this type of scenarios, we generally go for synchronous communication. When it comes to asynchronous communication, when services can work independently or when the response isn't needed immediately. For instance, in an order processing system, after placing an order, we might publish an event to a message queue like Azure Service Bus or Kafka for downstream services to process payments or send notifications. This decouples the services and improves scalability, as they don't need to wait on each other to complete tasks. The next commonly asking question would be, how do you deploy and manage multiple microservices in production? We generally use Kubernetes to deploy and manage multiple microservices in production. It handles container orchestration, scaling, service discovery really well. Each microservice runs its own Docker container, and we define deployments, services, and ingress rules using YAML manifests. For CI/CD, we set up pipelines in Azure DevOps or GitHub Actions to build, test, and push Docker images to a container registry like Azure Container Registry ACR. The pipeline also applies Kubernetes manifest to the cluster using tools like kubectl or Helm for templating. To monitor everything, we rely on Prometheus and Grafana for metrics, ELK stack or Azure Monitor for logs, and Kubernetes probes. It gives liveness and readiness to ensure services stay healthy for scaling. We configure horizontal pods, autoscalers based on CPU, memory, or custom metrics. If something fails, we use rolling updates or canary deployments to minimize risk. For example, we deploy a new version to a small percentage of users, first monitor it, and then roll it out fully if everything looks good. That's it, friends, for today. For more these kind of technical videos, please subscribe to my channel. Thank you.